Okay, now we're ready for Module 4. And this isn't going to take nearly as much time as the previous modules. There's a lot of information in Module 4 that we're not going to cover in this class. The main thing we're going to do in Module 4 is talk about one more aspect of trig graphs, and that's when you include this thing called a phase shift. So let's do a quick review of what we've done with trig graphs so far. So for instance, here's an equation that I want to graph. It's going to be a sine function. Once again, the standard equation for a sine function is a times sine omega x. So we've done this before. A is 4. Omega is 2. From the A, we can determine that the amplitude is 4. From the omega helps us calculate the period. So 2 pi over 2. Period's pi, and remember we always do our divide by 4. Divide by 4. So when we get ready to graph, we know every pi over 4 is a major spot. And now we have pretty much what we need. So my period, first of all, it's the amplitude. So we'll call this 4. We'll call this negative 4. Period's pi. So we break it up into 4 equal parts. We go halfway, pi over 2. Another halfway, pi over 4, which is our step. And this would be 3 pi over 4. And now since it's a sine wave, what happens when the angle is 0 for the sine? It's also 0, so we start here. And here are our 4 points, so we go up, back to 0, down, and then back. So if I were to try and draw the sine wave, it look like this. Now we showed a couple other extra things last class. One of the things we did was we showed what happens if you put a negative sign in front of the 4. Causes the graph to flip. I'm not going to go through that again. However, I am going to do one thing. I am going to include a vertical shift. Let's take the same equation and let's have a vertical shift. Remember, vertical shift is something you add way on to the end by itself. So this is this graph, but now the last thing I'm going to do is I'm going to do a vertical shift. Of -3. So here is the graph of 4 sine 2x. I'm going to take this whole graph. In this case, I'm going to move the whole graph down 3. So it's almost like this point goes to here, this point goes here, this point goes, oh, move it down 3, sorry. This point goes here. This point goes here. This point goes down to here. This point goes to here. So hopefully you can see basically there's a shift of -3. So then this is the graph of So the vertical shifts are actually pretty easy to figure out. But there's one more kind of shift, and that's called a phase shift. But a phase shift, it's almost like a horizontal shift. It causes the graph to go left or right. And a phase shift is a little trickier. The vertical shift is just whatever number is tacked onto the end, and you move the whole graph up or down that amount. Phase shift is not quite that simple. As a matter of fact, we're going to take our standard equation like right here. So here's the standard equation for the sine, at least what we've done so far. And here it is if we happen to have a cosine. To add the phase shift, what you do is we have to add another letter. It's going to be, the standard equation is minus, and you have this circle with a diagonal slash through it. And we do the same thing. And this, I think this, the Greek alphabet is pronounced psi, although it's spelled PSI, if I remember my Greek alphabet correctly. This, whenever you have this here, that means you're going to have a phase shift. In other words, this number is like inside the trig function. You know, this number right here for the vertical shift, it's just outside by itself. Here's the trig function. Whenever you have a number inside the trig function, you're going to have a phase shift, which means your graph is going to shift left or right. Now, whenever I have a phase shift, when I get ready to graph it, I'm really going to do the same thing as I do for the vertical shift. I'm going to sort of draw my graph, and I'm going to ignore the phase shift at first and draw the graph. And then the last step will then be to include the phase shift. So, easiest thing is just to do some example. Well, so here, let me explain what happens. We already know A gives us the amplitude. Omega allows us to find the period of our graph. Now the phase shift is going to be how much we have to move left or right. In the future, you'll probably see me just call this PS or P.S to abbreviate it. But the phase shift now is given by this equation, psi divided by omega. So the way we calculate the phase shift is we take whatever number is here minus something, that number there, and divide it by the number in front of the x. And that tells us if this is negative, that means you move the whole graph in a negative direction to the left. If this is positive, you move the whole graph to the right. So what happens is you do your normal things. You find the amplitude, you find the period. What I'm going to do is I'm going to find the amplitude and the period, and then I'm going to draw or sketch that graph like one of those dotted line graphs, like one of those temporary graphs. And then when I calculate my phase shift, after I do my dotted line graph, then I'm going to graph in the phase shift. I'm not saying you have to do that, but for me, that always seems like the easiest way, because this can be a little confusing sometimes. Easiest thing is, let's just do some examples. So I have a couple of examples to do. So here is an equation, 3 sine 2x minus pi. So right away, I can look at this because I'm subtracting a number, pi is a number. I'm subtracting something inside the sine function, I know I'm going to have a phase shift. So my general equation is A sine omega x minus psi. So I can say A is 3, omega is 2, and the psi is pi. So based upon that, amplitude's always easy. Amplitude's going to be 3. Period's pretty easy, right? 2 pi over omega, 2 pi over 2. Looks like the period's pi, and divide by 4. Looks like our steps are going to be every pi over 4. Now let's go ahead and calculate the phase shift, although I'm not going to graph it at first, but I will have to eventually. So the phase shift is psi over omega. So it's pi divided by 2. So what I'm going to do is I'm going to initially ignore the phase shift, and I'm going to draw the graph based upon the amplitude and the period. So amplitude is 3, so I'll 3 here, negative 3. Period is pi. So now I divide this up into 4 equal parts. This is pi over 2, pi over 4, 3 pi over 4. Now I'm going to, we've got a sine function, right? So it's 0, sine is 0. It goes up here, back to 0, down, back to 0. Except I'm going to do a dashed line because I know this is not going to be my final graph. So this is the graph without the phase shift. Now to include the phase shift, I found the phase shift to be pi over 2. That means I take this whole graph and I'm going to move it the distance pi over 2. Now if I look here on my scale, pi over 2 is like sort of 2 tick marks. So the easiest thing I do is I take every point on my graph and I move each point over, in this case 2 tick marks, and I'm going to draw an empty circle because that's my new graph. So this point, if I move it pi over 2 to the right, it's going to end up there. This point ends up there. This original point ends up there. This point ends up there. And this point ends up there. Now, if you can keep it all straight, now I'm going to connect these new sort of open circles. That's my new graph. If I did it correct, you can sort of see the dotted line graph has moved to the right, and this distance here should be pi over 2, which is my phase shift. All right, so sort of complicated, maybe not so much once you get the hang of it. Let's do one more example. Y equals 2 cosine 4x plus 3 pi. So we're going to have a cosine function because I know inside the cosine function I'm adding a number here. I know there's going to be a phase shift. So let's write down the standard equation. Notice here the standard equation is a minus. So that's going to become important in just a minute. So therefore I know A is going to be 2. Omega is 4. Here's where it's tricky. What should psi be? Some of you might think 3 pi, but really, because this thing has to be minus psi, and this is plus, turns out psi is minus 3 pi. If I rewrite this here, I can rewrite this as 4x minus a negative 3 pi. In other words, I want omega x minus 4x minus, and then what's in here? Minus 3 pi, which is my psi. So now, amplitudes 2, the period we can calculate. Divide by 4, actually. Each tick is pi over 8. And now the phase shift, which is psi over omega, negative 3 pi, and omega is 4, negative 3 pi over 4. That means my phase shift is actually going to move the graph to the left 3 pi over 4. All right, so let's see how ugly this is going to be. Let's first draw my initial graph. I'm going to draw the graph without the phase shift. So my amplitude is 2. My period is pi over 2. So I break it up into 4 parts. So this is like pi over 8. And 3 pi over 8. So let's do a dotted line graph without the phase shift. Since it's a cosine, we know it starts high, it comes to 0, goes low, back to 0, ends up high. Oh, I meant to do a dotted line, I forgot. This should really be a dotted line. It's not necessary, it just makes it sort of easier to tell apart. Now I have to factor in the phase shift. So I'm going to have to move negative 3 pi over 4 to the left. The reason this is sort of crazy is because 3 pi over 4, that distance is, if I were to keep going out here, I think this would be 3 pi over 4. This would be 5 pi. So really, this whole distance, that's how much 3 pi over 4 is. So I have to take this whole graph and move it in the negative direction, this whole distance. So it's really sort of crazy. So this point ends up going maybe, this is just going to be a rough estimate. Maybe this point goes here. This point goes like here. This point goes like here, maybe. This point goes here, maybe. So then, it's like from here to here is my phase shift. 3, actually I'll call it negative 3 pi over 4. So this actually is my final So, all right. So hopefully not too difficult to work into phase shift. And I believe that's about the last thing we're going to do now for now with trig graphs. So, all right.